Our first presentation is by Bethany, Giombetti, Carly Swingle, and Heather Stazetski, and it's called The Mystery of the Cosmos.
Hello, faculty, staff, students, and friends. We would like to thank you for being here this afternoon. My name is Heather Stazetski. I'm here with Carly Swingle and Bethany Giombetti. And today we will be presenting our findings on the Mysterium Cosmographicum, or as we would like to call it, the mystery of the cosmos. So before we begin discussing we want to know exactly what the mystery is. So was there a geometrical pattern that was governed by the planet's distances? We want to know how this all came about. Johannes Kepler had an epiphany one day in his classroom about the planets. So a little bit about Johannes. He was a German mathematician, astronomer, and astrologer. He was born in the mid-16th century and discovered his scientific theory in the mid-17th century. He lived in an era when there was no clear distinction between astrology and astronomy. And so at this time, there was no major development in technology to help with his research. He decided to use deductive reasoning to further his research. This approach is called the syllogistic thinking. This approach is a logical argument that uses and applies deductive reasoning to form a conclusion that is based on two propositions that are they're assumed to be true. So until this point, his model was the only thing that science kind of used to explain the universe. And until after that, they started to move towards the more mathematical understanding of the universe. So to begin talking about Kepler's model, we want to first focus on the 5 platonic solids, and they were originally hypothesized by Plato. He said that these 5 three-dimensional polytopes must be what the elements are created from the universe. And to discuss a little bit further about the 3D polytopes in the next slides will be Carly.
So first we're going to start by, finding what makes a solid platonic. So the faces on a platonic solid are made out of regular polygons. So for example, we have an equilateral triangle here. So each of the sides are of equal length along with the angles in between them. So you can think of a square or a regular pentagon. However, when we're creating platonic solids, we can't use faces that have 6 or more sides because if we were to put them together and fold them up, they couldn't create a 3D model. So to better explain that, I actually have 5 triangles here together. So we can see these 5 triangles, and in the middle here, we don't have a full 360 degrees covered. So we can technically add another triangle, but if we did that, we couldn't fold them together in order to create a 3D model. So if we fold them together, we can kind of see the start of a platonic solid that we actually have. And if we were to use regular polygons that had 6 or more sides, they would already encompass that full 360 degrees, and we couldn't create 3D models from them. So an example that we have here is called the icosahedron. So we can see that each face on this is made of equilateral triangles, and then each vertex that we have here has an equal amount of faces meeting at each vertex. And no matter which way you orient this, it's going to be the same, so this makes it a platonic solid. So to move on to the 5 that exist, we first have the cube, which is probably the most common that we know of. And like we mentioned before, Plato believed that these made up the elements of our universe. So he thought that the cube made up the earth because you can stack and balance it very easily amongst each other. He thought that the tetrahedron made of equilateral triangles made up fire, and he believed that the octahedron made up air. And in the next slide, on the right here, we can see the icosahedron, which I actually have here. Since it's kind of round, and you can imagine if you see water droplets moving down a window, they're round and kind of roll. So he thought that the icosahedron made up water. And since the 4 classical elements of water, fire, earth, and air were already taken, he thought that the last one, dodecahedron, which is made of the regular pentagons as faces, he thought that the gods used this platonic solid to make up the constellations that surround us. So now that we understand platonic solids a little better, we're going to look at what's called the Mysterium Cosmographicum, which is his theory. So in 2D here, we have a sphere, and then he put a tetrahedron around, or an octahedron around that, another sphere, and then an icosahedron, another sphere, a dodecahedron, another sphere, a tetrahedron, another sphere, a cube, and then lastly another sphere. So in here we can see the 5 platonic solids we just talked about in blue, And then in the white, we have 6 spheres. And at the time that Kepler lived, there was only 6 known planets. So his theorem was that the ratio of the radii of these 6 spheres was their distances from the sun. So we have a 3D model so you can get a better idea of what this actually looks like. So we start from the center and build out. We have Mercury, Venus, Earth, Mars, Jupiter, and lastly Saturn. And we can see the Platonic solids that we talked about inside of this. So another 3D model we have, this would be if the whole thing was put together and you cut the spheres in half so we could see inside what's going on. So we have all our Platonic solids in here, and these distances in here, or the radii, or what he thought was the distances from the sun. And if we zoom in here, we can just get a better idea of the details on the Platonic solids that we talked about.
So now that we know what this model looks like, we want to disprove this. So shown in this visual graph, these purple circles represent the ratios between the planetary radii. And so we compared that with the modern values, which are the black circles. And as you can see, these circles don't align very well. It's not awful, but it was actually said that there is an agreement of 5% within each planet of the ratios, which is pretty good, except for Jupiter, which was an outlier. So as you can see from this model, Kepler was not correct. These modern measurements actually show that this isn't how our solar system works. And plus, along with the fact that there are more than 6 planets now known, so with only having 5 Platonic solids, we can't prove that this theorem is true with more than 6 planets. So now that Kepler's model was disproven, what does he do next? Well, he doesn't actually continue with the Mysterium Cosmographicum. He actually takes some work from Tycho Brahe, who was a scientist. He took from his work and made his own laws of motion, his laws of orbits, areas, and periods, which are listed here. They are essentially dealing with planets and their elliptical orbit and the distances of their axes from the sun. So he took this Mysterium Cosmographicum of the distances in the ratios of the radii, and he applied it to more things in the universe, and he just developed that more. So how can we see Kepler today? Well, like I just mentioned about the planetary motion, it was actually known that Newton studied these laws of motion to come up with his own laws of motion and universal law of gravitation, which is pretty known today. Most of us have either been taught that or learned that in school, and it's widely used today. Another thing that Kepler is remembered by is a Kepler mission, which is a spacecraft that explores the structure and diversity of planetary systems. The Kepler mission is actually not in the space today. It ended a couple years ago, and the K2 mission went out. And the K2 mission is currently still out there, and it's expected to end like 2018, 2019. So scientists right now are still collecting data from this K2 mission. And Kepler, all of his accomplishments are shown through their remembrance in naming the spacecraft after him. So overall, the Mysterium Cosmographicum was an extraordinary idea that paved the way for the science of the universe. And Johannes Kepler was a huge advancement in this development of science, and he's remembered today through this epitaph. I measure the skies, now the shadows I measure. Skybound was the mind, earthbound the body rests. And here are some of our references. So we would like to thank you all for coming out today and listening to our presentation and learning a bit about the mystery of the cosmos. Right now, we will take any questions that the audience may have. If there are any. All right. Thank you.
Is this yours?
It should be, yeah. Yep, that one's on.
So our next presentation is by Jessica Booth, First Lady Jane Pierce, Applied Research in Performance. And same as we did last time, we'll take some questions for her at the end.
Once upon a time, there was a young woman from New Hampshire who met a handsome and outgoing young man. And though she longed for a quiet life with many children, when the man and woman were married, she was swept off by a team to a gloomy boarding house in Washington, D.C., and she was expected to be a politician's wife. Her first child died shortly after his first breath of Washington air. And when the woman became pregnant again, she made the man promise to get them out of that unholy swamp before she lost another child. And he did. And he did not hold an elected office for 10 years. And their perfect son, Benny, grew up sweet and kind and decent. And then one day, they were being pulled by horses through Cambridge when a man on a huge dark steed came galloping towards them. "You've been nominated for the presidency," he said to the woman's husband. And the woman fainted, dead away. And then, at first the man was surprised by the nomination, but it seemed only moments later he was president-elect, and they were being pulled by a steam-driven engine from Boston to Concord, when God derailed the train and sent their car toppling. And as they were toppling, the woman watched her perfect Benny soar from her arms and twist in two among the wreckage. The man and woman were barely scratched. At first she thought God had taken Benny so the man could be a better president with fewer distractions. And then, when she found out the man had been scheming for the presidency behind her back, she knew Benny's death was punishment for his lies. So she withdrew to her room in the White House. She wrote long letters to her Benny and fingered lockets of his golden hair for 4 long years. And she never did forgive the man for trampling their son so that he could smoke cigars and puff out his chest and say, "I am the President of the United States." People said he was a terrible president. Hello, everybody. My name is Jessica Booth, and this monologue is from the show 45 Plays for 45 Presidents, which I performed in earlier this semester. I did a lot of research for this monologue because the show goes through so many scenes and presidents that there's a lot to take in a little amount of time. And this particular scene needed to be a really powerful impact compared to some of the funnier or more lighthearted scenes. And only having so many words to do so, I really wanted to look into Jane's life and seeing what everything in this monologue meant and how she dealt with it in real life. So Jane Pierce is from New Hampshire. She married Franklin Pierce. Oh, that date is wrong, I apologize. She married Pierce in 1834 in New Hampshire. She did not particularly like his political career at all, but she went along with it, and she did in fact live in DC as the monologue states. And throughout her whole life, she suffered depression, which I found really interesting because looking at a timeline of her life, you can see where she went in and out of those phases. For example, with her letters to her sister, you can see where she's unhappy living in Washington, or when she has her son, she's very pleased to have a boy, as she lost 2 sons already, and then once more after the accident. So out of all of her children, none of them survived in the end. So the accident is the big part of the monologue. This is the emotional climax of it. And it happened on January 6, 1853 in Andover, Massachusetts. They were headed for Concord, and the train was derailed due to an axle turning over. And the entire car was flipped off the rail, as both pictures here depict. And unfortunately, Benny was caught between the floor and the wall as it separated, and it came down on his head, decapitating him. His mother and father had to watch that. Jane lost her only joy, her son, and her husband were physically unharmed, but they would never be the same emotionally ever again. So looking now at Pierce's presidency, he was the 14th president and he only served 1 term. And I believe that's largely due to the fact that he became a drunk. He became a drinker, and he was emotionally distressed due to his son. When it comes to the Civil War, he did nothing to stop it. In fact, he was part of the decision to make allow Kansas to choose between a slave or free state, meaning that tensions increased. So, along with all of this, Jane did not partake in any of her First Lady duties until about 2 years into his presidency. In fact, her sister and I believe her cousin did most of the jobs that Jane herself should have been doing. So when I looked at this coming into the show, This was my favorite part of the show, honestly. I love this monologue very much. It's easy to look at a monologue and words and figure out, okay, how would I feel? But with this particular scene, I had a historical figure, and I could look at how Jane reacted to the situation by isolating herself and not doing her job. You can really see the depression that hit her life, and that definitely impacted the way that I chose to deliver this scene. So for this play, I believe that I approached it with how she would feel, and I really, truly believe that by doing the research behind the scene that I was able to better portray the emotions through my acting. And this scene, in fact, got me a nomination for the Irene Ryan Acting Scholarship Competition to be held at ACTF Region 2 Festival next winter. Thank you very much.